In this video, I will be discussing our master project prototype. I will be going through some aspects of the case study documented in the report. And another note is that timestamps will be available in the description or in an associated text file, so that individual elements of interest can be viewed at these timestamps. So yeah, first thing, I want to create an account to our platform. So I'm just going to do that quickly and use a very simple and secure account. Once I've created this account, I can log in and I'll get the option to create data projects. So currently I have no data projects, so I will have to create it. As stated, I will take things from the case study done on the Højestene ferry. So I will call my data project Højestene. Additionally, I will set the data point interval. This data point interval is helps the system to specify how much data should be available. It also supports the interpolation approach and ensures that data series are aligned with each other. More details on this is found in the report. So I will create this data project. I'll then open the data project I just created, and I will be greeted by this screen. So up on the top, just some information about the data project is present, so my data interval and the name of the project. Below it, I have several menus that I can use to configure my data project. The first one, data sources, allows me to create or import data from a variety of services. Once I've imported these, I can select data series, and these data series will be available to the system and shown in this menu below. With the data series added, I can create aggregations, which are used to create metrics of interest. So in case of these ferries, typically that involves some fuel consumption metrics. In this case, in this video, I will show how to create daily fuel consumption and fuel consumption per round trip. Once created, these aggregates will show up in the menu below. Additionally, we can create transformations which enables us to take the input data series that we have defined from the data source and create new ones or tweak these in various ways. In this example, I will take the input data series and convert the units on them such that the aggregations can be created. And finally, down below here, we have different kinds of visualizations to show the data that we have created. So first, I will add a data source. The Højestene ferry has data placed on a service called Aldag, and therefore I will give my data source the name Aldag Højestene. If I could type. So, yeah. So in order to connect this, I have to provide an IP address of this service. So I will just do that quickly. So, quick note, this IP address looks a bit weird. That's because it's run within a Docker container, and this is the internal Docker container IP address. So yeah, I'll add this. Once I've added this, I will be greeted by a selection of data series. I do not have to specify them all, but just for the sake, I will just put them all in. Once selected, I can select the interpolation type and missing value replacement. The interpolation is useful for something like wind direction within degrees. The default is just a linear interpolation, but this does not work for wind directions or degrees, so 360. So here I will select a custom circular interpolation, and the same goes for the heading. Once I'm happy with my data series, I can add them to the system. Now, in the background, the system will start to import this data, and checks will be made every minute to look for new data. So we have to wait until a full minute before data will slowly start to be added. In the meantime, units are not shown for these, which is a lagging feature of the system currently, so that makes it a bit difficult to express these things. But for this display, it's important to note that starboard engine fuel, as it is here, is measured in liters per hour, and we can already see some of the data being added. So I will just show this in the visualization. Yeah, here we go. Oh, there's no data from port engine fuel yet, so that's why the illustration is not showing up. And it's starting slowly to be present. So while that happens, yeah. So in this data picker, I can select what duration of the data I want to look at. Since we have the spike, I would just like to look at a previous timestamp, and we can see here we have the data for both starboard engine fuel and port engine fuel as selected up here. Now, the next thing I will discuss is transformations, because before we can make these aggregates that get, for example, the total daily fuel consumed, I'll have to convert these from liters per hours into liters. So that's what I will do now. So I'll add a transformation, and I will be greeted by the following screen where I have to provide a name for the new data series that I'm about to create, and provide it with a formula that specifies how the transformation should occur. Since I have not created a formula yet, I will do that first. So I'll create a new formula. The goal of this formula is to convert the liters per hour to simply liters, such that I can create my aggregates that I'm interested in. To do this, I have to specify in the formula that I will have one input data series that I want to convert, and I will have one output that applies to, or I will specify the output based on the following function: data series x as data series 1x times. So what this formula does is that it takes any input data series and multiplies it by 30 divided by 360. Since both the starboard engine fuel and port engine fuel are in liters per hours, we have to convert it to liters. We can do this by looking at the data point interval, which means that they're data for every 30 seconds. So we can calculate how much fuel is spent for every 30 seconds using the following formula: 30 seconds divided by 360 seconds, that is on an hour. This might be a bit confusing, I apologize. But effectively what this does is it converts any input data series from liters per hour to simply liters. So I will create this. Once I've created this formula, I can select it in the transformation menu, and then I can specify the input data series that I want to apply. So we want both starboard engine fuel and port engine fuel to be transformed. I can only do them one at a time, so I will start with starboard engine fuel, and I will give this a good name. So this is starboard engine fuel in liters. I will create this, and the system will then process it, and I will have it available in the system. So here we can see the new transformed data series that is in simply liters for every 30 seconds. How many liters is spent on a 30-second basis. I need to create it for both, since there are two engines on the ship. So I will do the same thing for port engine fuel. Here the strength of the formula plays in, because I just have to specify that I want you to use the formula liter per hour to liters and apply it to the other data series. So port engine, and this time I will spell it correctly, I hope, in liters. I will create this. So now I have my two data series in liters rather than in liters per hours. This means that now I can actually create my aggregate that sums up the total fuel, since now I have data that specifies how much fuel is spent for every 30 seconds period. So first, I'm just going to refresh the page to avoid a bug. Yes, so I will create an aggregate, and the approach is very similar to transformations, with the exception that I need to specify the duration that the aggregate should apply to. So earlier I mentioned I wanted daily total fuel consumption, so I will specify that I want the aggregate to apply over 1 day. As before, I need to create a formula. This formula follows pretty much the same structure. This time, however, I need 2 data series because the total fuel for a day is specified by both the port engine and the starboard engine. So I will define 2 data series, and then I will use the aggregate function. So I will say output equals the sum of data series 1 plus the sum of data series 2. Note the language here is very general. I'm not saying that this is dedicated for fuel, but this is again to facilitate reuse of these formulas. So this formula simply is the sum of 2 data series. So I'll create this general formula, and then I can select it over here. And since I want the sum of port engine fuel, as specified here, starboard port engine, excuse me. As I want the sum of port engine fuel and starboard engine fuel in liters, I'll specify these as inputs, and I will give this a fitting name. So I have daily total fuel, and I will create this. Once I've created this, it was available in here, and I can click it, and then I get a bar chart of the daily average or the daily fuel. So if I skip the first one, that is, I think LDAC had some configuration problems during the first couple of days, so I'm just gonna skip these, and then I'm gonna select this. So if we apply again, we got the daily total fuel over the course of 4 days from the 12th of October to the 16th. And here we can see we are spending, on the first day, we're spending 522 liters, and it looks like we are moving up to 800 liters on a daily basis. So we have already created some metrics now. These are not very specific, so it's hard to investigate the data why maybe the total daily fuel on the 12th of October is so much less than the following days. So maybe we want to separate the data into individual round trips instead. So for the Højestene ferry, a round trip is simply leaving the port in Drejø and visiting 2 other ports, and then coming back to Drejø. This constitutes a round trip, and there are several of these per day. So I kind of want to separate the data into this, such that I can get the total fuel for each individual round trips, which will be a bit easier to compare with each other. This is done in the system, again using transformations. So I will create a transformation as before. I need to specify a new formula, and I have to define a formula that outputs what we call a labeled data series. So I will copy over some pre-made code, and we'll just discuss it briefly. So as I said, a round trip consists of visiting several ports. This is determined by different geofences. In case of Højestene ferry, it will visit a round trip starts and ends at Drejø Havn or Drejø Harbor. So we will create a geofence around Drejø Harbor, which we will use to specify when a round trip starts and stops. To do this, as mentioned, we need a geofence, And for that, we need to have the latitude and longitude data series as input. That's what I define up here. Then we want to separate the data into when we are on a route, so that would be the on route label. And then we want to define when we are not on a route to separate these two situations from each other. And we do this by defining a label called docked. Then comes the logic that actually does the separation. So in the default case, we assume that we are on route. So initially we define all data series points as being on route. Then, given the geofence stated here, so that would be a condition statement where we say that if the latitude is below this and the longitude is below this, well then we know based on inspection on Google Maps that we are in one of the harbors, in this case in Drejø Harbor. So that is what this transformation does. So it separates the data into round trips effectively, if the explanation was a bit difficult to follow. More details can be seen in the report, which should be a bit more clear. So this is the round trip labeler formula. So I will create this, and then as before for the other transformations, I specify that I want to use the round trip labeler formula. I have to specify the latitude and the longitude. The ship is equipped with sensors for this, or with a locator for this. So we have a data series for latitude and we have a data series for longitude, which I will select. Then I will give this a name and I will call it round trip labels, and I will create this data series. This will result in a new data series, transformed data series, called round trip labels, and I can visualize this as any other data series. Oops. One specific thing with labeled data series is that the y-axis is slightly different. So over to the left we can see that we have on route and docked labels on the y-axis to show the different labels that we're in. So we can see we got the data and we have long durations where the ship is docked. This is because overnight or at the end of the day the ship is docked in Drejø Harbor. So there is no round trips happening in this duration here. Then in the morning we will go on our first route, come back to Drejø Havn, then go on to the next, back to Drejø Havn, and then on the final round trip. This information is useful for comparing different sections of data, for example. So by selecting label data series here, I get my round trip labels. I have an option for various labeled sections. So I can inspect a specific route. So let's say this round trip on the 12th of October, starting 6:44 to 10:21 in the morning. I can inspect this and maybe look at the fuel consumption for this period. And then I get it visualized for this starting from this section. I mentioned that you can compare these, and by pressing this button out here, I can select another labeled data section. So I can find another period. Maybe we will want to look for the following day. Oh, there was no data, so we have to skip to the 14th or maybe the 15th. So I'm just gonna go with the 15th of a similar round trip. And I can then compare these. To make it a bit more clear, I will just look at startup board engine fuel and I will compare these. So we are greeted by two data series. One is called starboard engine fuel, marked in red, and the other is called the same but has appended compare. The green data series, ending with compare, is the one shown in the second selected labeled, and the red one is associated with the first labeled section. So this can be used to compare different sections. Currently we do not have a good overview of which section might consume more fuel. So another useful thing about round trip labels is that we can create aggregates over them. What this means is that, like for daily total fuel, I can add another aggregate, and rather than using running time, if I check this off, I can aggregate over my labels. In this case, I will have to refresh the page because the GUI does not automatically update. If I do this again, I can aggregate over labels, and we have our round trip labels here. Since we're interested in the same daily total fuel, I will just reuse the formula that we created for daily total fuel, sum of two Dataseries, and select starboard engine fuel in liters and select port engine fuels in liters. To distinguish between them, I will give this the round trip total fuel, and I will add the aggregate. Then I can get this visualized, and again I will remove the first part of the data that is not correct, and a slightly smaller period. I'll apply this. I'll actually maybe a couple more days. So as before, I get a bar chart, and this time the bar chart is separated into each of the different mode or the different labels. So we have the duct that are typically not interesting because that is typically associated with staying overnight at Drejøhavn. More interesting is the en route aspect. So this is when we are on a round trip, and we can see here we are consuming a varying amount of fuel. Below this, just quickly, there is some metadata on the on these different labels. So we can say that there are 15 sections of duct labels and 15 sections of en route labels. And the ducts spent 3,000 minutes, while the en route spent 2,600 minutes over the duration that we have specified. Back to the visualization. Here we can actually see that on the 15th of October, on the round trip starting from 14 o'clock, we are spending significantly more fuel than for the same round trip on the 13th. So maybe we want to look at what makes these different. So we use the label data series as we did before, but this time we use our aggregates to guide our comparison. So we want to compare the 13th of October. Let's see, 13th of October from the en route period of 14. We want to compare this to the round trip that consumed the most, and we can find this one as well. 15th here, and then we can compare these. And if we, rather than speed over ground, we take our port engine fuels and compare these, we can actually see that for the second round trip, marked in yellow and blue, note the compare behind, that we are actually consuming significantly more fuel. If one is an expert in maritime vessels, maybe one can figure out why this is. My immediate reaction would be to look at the wind speed. Maybe the wind speed will tell us something. But looking at this, it doesn't look like there is that much difference. It could be that, but I don't know. But yeah, this was a showcase of our master platform, master project prototype. More details and more interesting visualization and conclusion can be found in the report. During the report, we will reference each of these sections if you want to look back later when reading the report. But yeah, this concludes this presentation.